Okay, Unit 8, Day 6, the law of sines. Just to review, we got to talk about how triangles are labeled. Okay, there's a difference between the way that we label a point or a vertex and the way that we label a side. Okay, so before we can move on into the law of sines, we have to get that down. Okay, so points and vertices on a triangle are represented by upper case letters. In other words, capital letters. So if I come down to this triangle and I want to label the points, the vertexes, the vertices, I'm going to use uppercase letters to do it. Okay. The sides themselves, the sides of the triangles, we use lowercase letters. And the way that I label the sides, the way I choose which letter to use, is the side is the letter of the angle that it's across from. So if I want to label this side right here, I could call it BC. Another way to label it would just be to call it side A, but I'm going to use a lowercase a. And if I want to do side AB right here, if I want to just give it one letter, I use the angle that it's across from. And so I'm going to make it a lowercase c. And then for the side at the bottom, since it's across from angle B, I'm going to call it lowercase b. Okay, so that's how we label a triangle. The angles or the vertices, we use an uppercase letter, and then when I want to label the sides, I use the lowercase version of the angle that side is across from. So what I want you to do now, pause the video and do what I just did to this triangle right here, but with these points and sides, FGH, that I've given you over to the left. So pause the video, try it on your own for a second, and then when you unpause the video, I'll show you how it should look, or how it could look. Okay, so hopefully you tried this yourself first. There's not one way to do this, but if I was going to start, I would put the angles on here. So you could do like FGH, or you could do GHF. It doesn't matter, just so that you have the three vertices of this triangle labeled with capital letters. Okay, the reason I do that first is because now the sides, lowercase f, lowercase g, lowercase h, go across from whatever angle, or I determine which lowercase letter to use based on which angle they're across from. So since this is capital F, I go across the triangle, put a lowercase f right there. That's side F. And across from angle H is the hypotenuse. So I'm going to put an H. And then across from angle G is that side. So that's how this triangle could be labeled. Yours doesn't have to look exactly like this, as long as you have a capital letter at each vertex, and then the sides are labeled based on the angle that they're across from. Okay, the first new thing is we're going to use trig ratios to find the area of a triangle. Okay, so this is going to work on any triangle. Before, when we were doing stuff with the trig ratios, we were just using right triangles. But now, to find the area of any triangle, we can use trig ratios. And I'll show you how in a second. But basically, before today, the only way you would have known, if you remembered at all, how to find the area of a triangle is 1/2 base times height. So the base in this triangle would just be like the bottom side here. The height would be the distance from the highest point on the triangle to the base. If I knew those two numbers, I could figure out the area of a triangle. But let's say I don't know those two numbers. I can use one of these formulas right here instead. Okay, so I would need to know two sides and their included angle. In other words, two sides and then the angle between them. Right? If I know that, if I know those three things about any triangle, I can figure out its area. And again, area just means like how much space does the triangle take up. So maybe this will become clear when I do an example. And there's only one example here. I'm not sure why I put examples 1 and 2. This is just example 1. So I have this triangle here, ABC. I know that side B, right, because it's across from angle B, I know side B is 8 millimeters long, and I know that side C right? Because it's across from angle C. I know that one's 7 millimeters long, and I know that angle A is 86 degrees, okay? So I know two sides and their included angle, so I'm basically going to plug them into which formula? Let's see, I know B and C and angle A, so I'm going to use this middle one. Area equals 1/2 B times C times the sine of angle A. Okay, so now I'm just going to plug in the things that I know. A equals 1/2. What's B? Well, B is 8. What's C? C is 7. The sine of angle A is 86 degrees. So I'm going to find the sine of 86, and it's 0.998 basically. So I kind of jumped ahead of myself, but the sine of 86 degrees is 0.998. 1/2 times 8 times 7. Here's how I do that. 1/2 is 0.5 times 8 times 7 is 28. So the area equals 28 times 0.998. So the area of this triangle is 27.94. And that would be millimeters squared. Okay, the other example doesn't give me the triangle, but it does give me some information. I'm going to draw it out first. So I don't really know what the triangle looks like, so I'm just going to draw kind of a generic triangle. I'm going to call this down here angle A, and it tells me that's 40 degrees. And then I would have B and C. It tells me that side B is 11 centimeters. So that would be this one over here, right? Because it's across from angle B. And then side C, which would be over here, is 6 centimeters. So the area of this triangle equals 1/2 B, C, sine A. So the area equals 1/2. What's B? Well, side B is 11. Side C is 6. Now I need the sine of angle A, which is 40 degrees. 0.643. So I'm just going to get my calculator out. For 1/2, I just type in 0.5, because it's the same thing as 1/2, times 11, times 6, times 0.643. So about 21.22. And this time it's centimeters squared. And that's that. All right, now we're actually going to get into the law of sines. But what I want you to do before you start is recreate this triangle that I have over here on the right. So pause the video for a second. Make sure you have that triangle drawn about how I have it. It doesn't have to look exactly like I have it, but just something like that. All right, now I can explain what this law of sines actually means. Here it is right here, and it's pretty simple, really. It just says that when I have a triangle, the sine of an angle over the side that's opposite from it, that ratio there is equal to either other angle divided by the side across from it. So for example, if I knew what the sine, what angle A was, like how many degrees it was, and I knew what side A was, how long it is, and then let's say I knew what the measure of angle B was, I could figure out what side B was. Okay, so here's the formula right here. Usually we're not going to use all three of them. Most of the time what we'll do is we'll set up an equation with just these two or something to solve for one of those four things that we don't know yet, right? We have four things here. Usually what we're going to use the law of sines for is to figure out angle A, figure out angle B, figure out side B, or figure out side A, okay? But what's cool about this, or what's useful about this, is that it works for any triangle, not just right triangles. So kind of like the area thing that we just did a minute ago, the law of sines works for any triangle at all, even if it's not a right triangle. So if it's right, acute, or obtuse, we can use the law of sines. Here's how we do it. So let's say I'm working on this triangle on the left. And I know two of the angles, and I know one of the sides, and I want to find this other side down here. What I do is I come up to the formula itself to see how I'm going to set it up. What do I actually have right now? Well, I know angle A is 35. I know angle C is 85. And I know side A. Okay, so what I'm going to actually use here, like I said a minute ago, I'm not going to use all three of these in a row usually. I'm going to use this one and this one, right? I'm going to set those two ratios equal to each other, plug in the stuff that I know, and then solve for the thing that I don't know. And so what that looks like is this down here, right? Sine of angle A over the sine of angle C, sine of angle A over side A equals the sine of angle C over C. So angle A is 35, so let's find the sine of 35. And it's 0.574. Side A is just 5. Okay, now I need the sine of angle C, which is 85. And it's 0.996 over x. Okay, when I want to solve this, I just cross multiply. So x times 0.574 is just 0.574x, and then 5 times 0.996, 4.98. And there's one more step. I didn't really leave enough room in the box. So x is equal to 4.98 divided by 0.574. So x, in other words, this side right here is about 8.67 units long. Okay, let's do the other triangle. So I'm going to erase this stuff that I had before just to show you how I know how to set this one up. Depends on what information I have. So I'm looking at this triangle over here on the right. What stuff do I have? Do I have angle A? No. Do I have angle B? Yes. Do I have angle C? Yes. Do I have side B? Well, that's x. And I know that side C is 5. So the two parts of the formula I'm going to use is sine B over B equals sine C over C. And I already have that for you here. Let's just plug in what we know. Angle B is 60 degrees, so I need to figure out the sine of 60 degrees. It's 0.866. And side B is my x in this case. Right? The side across from B is x. Sine of angle C, well, angle C is 85 degrees. So I need the sine of 85 degrees, 0.996. And side C is just 5. So it's another cross multiplication problem here. I have x times 0.996. Oops. Going the other way, I have 5 times 0.866. Last step, like on the other problem, was to divide by whatever the coefficient of x is. So x is just equal to whatever 4.33 divided by 0.996 is. .35. So in this triangle, this side up here would be about 4.35 units long. All right, next we're going to try and solve a triangle using the trig ratios. And if you remember from last week, if I'm solving a triangle, it means I'm just trying to figure out everything about the triangle that I don't already know. So here's the problem right here. And so it doesn't give us a picture, and that's what I'm going to start by creating. So it doesn't have to be perfect, it just has to be a triangle. This is going to allow us to see what we have and what we don't have. Once I know what I don't have, I know what I need to find. So it's triangle NPQ. So draw this along with me. I have triangle NPQ. So each one of these is an angle. And I know that angle P is 42 degrees and angle Q is 65 degrees. And then I know that side N, so the side that's across from angle N, is 5 units long. So the things I don't know right now are side Q, and I don't know side P, and I don't know what angle N is. Let's call it X for now, X degrees. So that tells me what I need to find. So I'm going to start by finding angle N. To find angle N, all I really need to do is remember the triangle angle sum theorem, right? The idea that all three angles inside of a triangle have to add up to 180, right? So I don't know what I was putting that angle A there for, but let's just say 180 equals whatever angle N is plus 42 and 65. So 42 plus 65 is going to be 107. So 180 equals angle N plus 107. So angle N itself is just 180 minus 107. So angle N would be 73 degrees. So I can erase this angle X now because I know what angle N is. It's going to be 73 degrees. So now I know all the angles inside of the triangle. Now I can use trig ratios and more specifically the, the law of sines to figure out the other sides, Q and P. All right, well, let's say I want to find side P here. I know enough to figure that out now. All right, so I want to find side P. And what would probably help here is if I rewrote the law of sines, just as a little guide to myself, with these letters inside, instead of A, B, and C like I had before. So the sine of N over N is going to be equal to the sine of P over P. Those two are both going to be equal to the sine of Q over Q. All right, so P is one of the things that I want. Do I know angle P? Yes. Okay. Do I know angle Q? Yes, but do I know side Q? Yes. No, it's just a Q right now, so I can't use that one. Do I know angle N? Yes. Do I know side N? Yes. So the ratio I'm going to use is just these two parts right here. Sine of angle N over N equals sine angle P over P. Okay, so the sine of angle N is going to be the sine of 73 degrees. So 0.956. So I'm going to do it over here. 0.956 over side N, which is 5, equals the sine of angle P. So I need the sine of 42 degrees. 0.669 over P, which is what I'm looking for. So cross multiply, and I would have 0.956 P equals 5 times 0.669. 3.345. And then divide both sides by 0.956. So P would come out to be 3.345 divided by 0.956. So about 3.5. I'm just going to call that 3.5. So side P now, I know, is about 3.5. Okay, the only thing I have left to find here is Q. And I can really use any trig ratios here, or any parts of the law of sines that I want. Let me go back, unhighlight these things. All right, so the one that I want, the thing I'm looking for is Q. And I know angle Q. So I can use sine P and P, right? Because I just figured out that P is 3.5, and I know angle P is 42 degrees. So I have a little bit more space here, so maybe this will be a little bit more useful. So I'm looking for side Q. So I'm going to set this up down here. Sine of angle P over side P is going to be equal to the sine of Q over Q. Angle P is 42 degrees. So I need the sine of 42. 0.669 over side P, which I just found is 3.5. That's going to be equal to sine Q over Q. So Q is 65. So I need to find the sine of 65. 0.9, let's call it 0.91 over side Q, which is the thing that I'm looking for. Okay, so I'm going to cross multiply. So I'm going to have Q times 0.669. That's just going to be 0.669 Q equal to 3.5 times 0.91. All right, 3.17. Last step, divide by whatever the coefficient of the variable I'm looking for is. So I'm going to divide by 0.669. Q is going to come out to be 3.17 divided by 0.669. 4.74. So this last side of the triangle that I was looking for, Q, 4.74 units. Okay, next example wants us to solve another triangle, this time with a little bit different information. And something weird's going to happen on this one. Okay, so I'm going to draw the triangle here, or try to. It's triangle RST. You should draw this along with me. This angle right here, angle R, it tells me is 95 degrees. Side R is 10, and side S is 12. Okay, so if I was going to solve this triangle, I would need to try to find everything else I could about this triangle. So angle S, and then side T, and then angle T also. So the first thing I'm going to try to find here is angle S. I'm going to try and find angle S first. So if I rewrote out the law of sines for this triangle, it would be the sine of S over S equals sine of R over R equals the sine of T over T. And so because I'm going to try to find angle S right here, let me highlight what I'm going to actually look for. I'm looking for angle S. I know side S is 12. Which other one am I going to use? Well, do I have angle R? Yes. Do I have side R? Yes. So I can use these two. So let me just plug in what I know. Well, what's the sine of S? Well, we don't know yet. That's what we're looking for. We don't know angle S yet, but I do know side S right here is 12. And angle R is 95, so I'm going to look for the sine of 95 degrees over R, which is 10. So sine of 95 degrees. Oops, I did that wrong. Okay, 0.996. So sine of S over 12 equals 0.996 over 12, over 10, sorry. All right, now I'm going to cross multiply. So on one side, what I'm going to have is 10 times the sine of S. So 10 times the sine of angle S equal to, on the other side, I'm going to have 12 times 0.996. All right, and when I do the math here, on the left side, I have the sine of angle S times 10. I'm going to leave that alone for right now, and you'll see why in a second. On the other side, I have 12 times 0.996, 11.95. So I have 10 times the sine of angle S equals 11.952. All right, if I want to get the sine of angle S by itself, I got to get rid of this 10. So I'm going to divide both sides by 10. Come down here. On the left side, those two are going to cancel. So it's just going to leave me with the sine of angle S being equal to 11.952 divided by 10. Which is 1.952. 1.1952. Okay, here's where things get kind of weird. Normally when I want to do this, I would write out that set of instructions for you. You do second function sine 1.1952. But watch what happens when I try to do that. If I try to take the inverse sine of 1.1952, invalid input. What that means is that it's impossible to take the sine of this number. That means that a question like this, there is no solution. In other words, this triangle is impossible. This can't be, you can't have a triangle with an angle R of 95, a side R of 10, and a side S of 12. And so if you get to the point where you're doing a problem like this, and your calculator says invalid input or error or something like that, you just stop right there and you just write no solution. Okay, another one like the last one, but I promise this one will have a solution. First thing I want to do is I'm going to draw the triangle to help me see what information I have and what stuff I still need to find, right? So this is triangle M, N, P. What do I know? I know angle N up here is 32 degrees. I know side N, so the side across from angle N is 7. And side P, side across from angle P, is 4. So the stuff that I don't know, what's angle M, what's angle P, and what is side M. So the things in red are the things that I don't know yet. I'm going to rewrite the law of sines with these letters. So the sine of M over M is going to be equal to the sine of N over N. Those two are both going to be equal to the sine of P over P. All right. Where am I going to start? I'm going to try to find, let's find angle P. Let's find angle P. So I want to find angle P, and I know that side P is 4. Which other one could I use? Well, I know both things for N, right? I know angle N, and I know side N. So I'm going to use these 4 things. And rather than rewriting it, I'm going to substitute things in as I go. So the sine of angle N is going to go up here. Okay, so the sine of 32 is going to go on top. So 32 sine. So 0.529. I'm going to round that up to 0.53. And then N, side N, goes on the bottom, and side N is 7. Okay, on the right is going to be the sine of angle P, and I don't know angle P yet, so I'm just going to put sine P. I do know side P is 4, though. So, cross multiply. On the left side, I'm going to put 4 times 0.53. So 4 times 0.53 is 2.12. So over here I have 2.12. Over here I have 7 times the sine of P. I want to eventually get this angle P by itself, so what I have to do here is I have to get rid of that 7. So I'm going to divide by 7 on both sides. So 2.12 divided by 7 is 0.30. I'm going to call that just 0.30. 0.3 equals those two have canceled. So on the other side, I just have sine p. All right, so this is where I'm going to do the second function and then hit sine, and then this value right here, 0.3, and then enter. So that's what you're going to do on your calculator. Mine's going to look a little different. So I want the inverse sine of 0.3. So about 17.46 degrees. So angle P right here is about 17.46 degrees. Okay, now I need angle M and side M. I can find either one first, it doesn't really matter. The easier one to find is going to be angle M, because I know that these two together subtracted from 180 is going to be whatever angle M is. Right? Angle M, actually 180 equals angle M plus 32 plus 17.46. So 180 is angle M plus these two added together, which would be 49.46. So now I'm just going to subtract 49.46 from both sides, and that'll tell me what angle M is. So angle M is 130.54 degrees. So if I would have drawn a more accurate triangle, right, this angle would be a lot bigger, right? I just sketched in a regular, almost equilateral triangle. But if I were actually drawing this triangle, it would look a lot more like this, right? Angle M would be really big. But we'll just stick with the one that I have for now. We're not drawing the triangle for accuracy. We're drawing it more as a way to help us see what we have and what we don't have. All right. The only thing I have left to find is M here, side M. So I'm going to go back to the law of sines and look at what I have and what I need. And I have options now. Okay, so side M is what I'm looking for. I know angle M, so I'm definitely going to use that part of it. And then I also know angle N and side N. So I'm just going to use those two things. And like I did to start this problem, I'm not going to rewrite this. I'm just going to plug things in as I go. I'll use blue so we can see where I'm working. Okay, sine of angle M. Okay, so I need the sine of 130.54. So 0.76, let's call it 0.76 over side M, which is what I want to find. And that's going to be equal to the sine of N. Okay, so N is still 32 degrees, which is 0.53, over side N, which is 7. Cross multiply, so on one side I have 0.76 times 7, just 5.32. That's going to be equal to M, well, I don't need to write it like that, it's just going to be 0.53 M. Last step here would be to divide by the coefficient of M. So M is just 5.32 divided by 0.53, which is just over 10. I'll call that 10.04. So this side over here, rather than putting an M there, I can now write 10.04, and I'm done.